What if the universe isn't what we think it is? Not a vast emptiness sprinkled with stars, not an endless dance of matter and energy, but something deeper, colder, and more calculated. Something that doesn't just follow rules, but runs them. Imagine that everything, your screen, your thoughts, the laws of physics, isn't the result of chance, but of computation. A quantum computation, not a simulation, not a metaphor, something real. What if the universe is a quantum computer, a cosmic processor that's been running for 13.8 billion years? Every atom, every photon, every interaction is not just a reaction, it's a calculation. Every passing second, a step in an algorithm. In this view, you're not just made of atoms, you're made of instructions. You are the output of the universe's ongoing computation. For centuries, we viewed the cosmos like a machine, a physical system of particles and forces. Drop a ball, it falls. Light a match, it burns. But the more we look beneath the surface, the more we see something strange. The laws of nature seem to be processing information, not metaphorically, literally. Physicists and computer scientists are increasingly converging on a radical idea. Information isn't just an abstract concept. It's physical. It can be measured. It can't be destroyed. When a quantum state collapses or a star explodes, information changes. And that change has consequences. John Wheeler, who worked alongside Einstein, summed it up in 3 words: it from bit. Every field, every force, every event may ultimately arise from binary choices: yes or no, 0 or 1. Sound familiar? That's how computers work. Digital systems take inputs, follow rules, and produce outputs. In machines, this happens through circuits. In the universe, it happens through physics. The equations of electromagnetism, gravity, and quantum mechanics don't describe things. They describe how information flows and evolves. Zoom all the way down to the smallest scale, the Planck scale, and the smooth fabric of reality breaks apart. Some physicists believe that space and time are not continuous but granular, like pixels on a screen or frames in a film. Reality might be discrete, not smooth. It may function more like code than clay. Even particles are quantized. They have discrete properties like energy levels. DNA is a code. Electrons are data. And you? You're an expression of a cosmic instruction set. If this is true, the laws of physics aren't just discovered, they're written. They are the source code of reality. Everything we see, from galaxies to grass, is what happens when those rules run long enough. There's another twist. If reality is digital, it must be finite. According to the Bekenstein bound, you can only store a certain amount of information in a given region of space, based not on its volume, but its surface area. Black holes seem to obey this rule perfectly. The information that falls into them isn't lost. It's encoded on their event horizon. This is the holographic principle. What appears 3D may be a projection of 2D data. The entire universe could be just such a projection. Even if the universe isn't literally a hologram, it behaves as though it's fundamentally made of information. Forces aren't just pushes and pulls. They're methods of transferring data, mass and charge, labels for how information is stored and exchanged. And this is where quantum computing comes in. Regular computers use bits, 0 or 1, but quantum computers use qubits, which can be 0 and 1 simultaneously thanks to superposition. When you entangle qubits, they become linked in ways that defy classical logic. What happens to one affects the other, instantly, even across space. These aren't science fiction ideas. They've been proven again and again in labs. Quantum computers can solve problems classical machines can't touch. But more importantly, they don't just simulate quantum mechanics. They are quantum mechanics. They use the same rules the universe itself uses. And that's the point. If the universe operates through quantum rules, if it processes information the same way, then maybe it doesn't just resemble a quantum computer. It is one. Black holes might not be exceptions. They might be examples. Some physicists believe they're the universe's ultimate information processors, scrambling, storing, and eventually releasing data in Hawking radiation. And then there's the emerging idea that spacetime itself might be a result of quantum entanglement. Mark van Ramsdonk and others have shown that when you entangle enough quantum systems, a geometry emerges, one that resembles spacetime. Space might not contain entangled particles. It might be entanglement. The very connectivity of the universe could be built from shared quantum states. Tensor networks, mathematical structures used in quantum computation, have shown that when you model entanglement correctly, the resulting geometry looks like curved space. That's not a metaphor. That's computation giving rise to space itself. Even quantum error correction, the way quantum computers protect fragile information, has found its place in fundamental physics. Some models of spacetime appear to work like massive error-correcting codes. The universe seems to protect its own structure by distributing information across regions like a vast, fault-tolerant system. And that changes how we think about laws. Maybe gravity and electromagnetism aren't separate forces. Maybe they're subsystems, modules in a larger code base. What we call constants of nature might just be the default settings for our region of the computation. In another region, a different part of the multiverse, those settings could be different. This redefines how we see energy too. In classical physics, energy makes things happen, but in information theory, energy and information are linked. You need energy to process or erase information. If the universe is computing, then the Big Bang might not have been a bang at all. It might have been a boot up. The second law of thermodynamics, the law of entropy, might not be about decay, but about expansion. As time moves forward, the universe explores new configurations of information. Entropy isn't chaos, it's possibility. But even quantum computers have limits. They need power. They face heat and noise. Eventually, the universe may run out of usable energy. The computation could slow, then stop. The heat death would be the ultimate freeze, not just of temperature, but of information flow. Still, even in that far future silence, the information might remain, trapped, frozen, but preserved. Some theorists even suggest it could loop, spawning new complexity by random fluctuation. But for now, we're in a rare phase, an active period of cosmic computation, rich in structure, energy, and awareness. And here's where it gets truly strange. We, the observers, are not standing outside the machine. We are inside it. We are quantum systems made of data, using the rules of the system to understand the system. Consciousness is information folding in on itself, computation becoming aware of computation. So, what does it mean to say the universe is a quantum computer? It means reality is a process, not a place. It means structure, thought, life. They're not accidents. They're what happens when information flows through a system like this one. It means we're not just watching the machine. We are the machine. And in this fleeting moment, while the computation still runs, we get to ask, what is this? How does it work? Not because the answers will be easy, but because we're built to ask them.